Have you ever wondered how air conditioning works? Or have you ever wondered how the refrigerator at home manages to keep things cold even when the day is super hot on a summer? So I asked several people this question, and while some of them gave me a good answer, some of them said these machines kept things cold by producing coldness. This was a very common answer. And the next common answer was people said these generated chill air. What would your answer be? Think about it. So, to me, while these answers are correct in a way, and I do agree with them, they don't very accurately describe what goes on inside of a refrigeration unit. So, in the next few videos, we will break down the whole process and understand the fundamental principles of refrigeration and how it works. Trust me, this is going to be the easiest to understand explanation of how refrigeration works. So, let's jump in. So, to understand how refrigeration works, we need to understand what it means for something to be cold. Why are we saying that something is cold? So, let's understand what coldness is. And to do that, we'll play a game now. So, this game is called Which is Colder? So, there's two images on screen now, a mug of coffee and lava. Which one is colder? In this case, it's definitely the coffee. Next, coffee or water? We're moving our answer now. It's not coffee that's colder. In this case, it's the water that's colder. Next one is ice cubes. Which one is colder now? Water or ice cubes? Ice cubes. Is one more image. That's the sun, by the way. So, the sun or the lava? In this case, which one is colder? Well, I have to say it's the lava. But wait, what is going on here? Did we just call lava cold? Well, you might be starting to see where I'm going with this. Hotness and coldness are are just adjectives in the English language, and they are just used to express how something feels. Thermodynamically speaking, everything has a certain amount of heat. If we're saying the sun or the lava has heat, or even the coffee has heat, well, sure, they do. But so does the ice. Ice cubes have some heat to it as well. And it is just the level or the amount of heat that something contains which makes us perceive it as hot or cold. We said lava was colder because it has less heat than the sun. Everything has heat, but the sun has more heat than the lava, which has more heat than a mug of coffee, which has more heat than water, which has more heat than ice cubes. So now we are somewhat able to define what coldness is. For something to be cold, it just means that it has less heat than something else. Now let's just bring that same concept over to refrigeration. So I'm drawing a box here. This is my fridge, imagine. I'm drawing another big box around it. So this is the room where the fridge is kept. So earlier, when we started this video, we said that the fridge is colder, or we said that the fridge is cold and the room is warm. Now, after we understood a little bit about the thermodynamics of heat, we are going to correct this statement and we are going to say that the fridge, rather than saying it is cold, which is also correct, in other words, we can say that this has less heat. A refrigerator in a room always has lesser heat, and that's why we perceive it as cold. But how did that happen? Before you switched on this refrigerator, you just bought it from a store and put it in. Before you switched it on, it must have been the same temperature as the room. It would not have been colder, it would not have had less heat. The room and the refrigerator would have had the same heat. But after a while, you switched it on, and then the temperature or the heat that this refrigerator had reduced. This can only mean that somehow heat has left the box. By some means, we pushed heat outside of this refrigerator, thereby making it colder. But is it really that easy? Could the heat really just have moved from inside the refrigerator to outside into the room? So, to answer those questions, let's get into a short side discussion here. The fundamental rule here is that heat does flow. So, that is one question we can easily answer. It does move from one place to another. But it is constrained in a way that it can only move from a zone of more heat to a zone of less heat. So, heat can only move in this direction. If there is some hot coffee, if you place a cup of coffee in a room that is cold, heat will only go from the coffee to the room, and eventually the coffee will become colder. There is no way that heat will go from the room inside the coffee. There is no way that the coffee will automatically start becoming hotter. So, heat can only move outside of the coffee in all directions. So, that's why a cup of coffee that is kept in the open becomes cold after a while, or it becomes less hot as per our newer definition. You can imagine this by thinking of heat as packets of energy. The thing about energy is that it likes to be balanced, it likes to be distributed. It does not like to accumulate inside a certain space. So, if you take this coffee here, you can imagine the coffee to have lots of small heat energy packets. The room outside of it doesn't have as much heat. So, the heat outside in the room is going to be very distributed. So, by its nature, heat does not like to be concentrated like this inside. It does not like to be accumulated together. So, what it'll try to do naturally is it'll try to disperse. So, some of this heat energy will just start going out into the atmosphere like this. It'll just start going out, and eventually there will reach a point when there is an equilibrium between the cup of coffee and the room around it. And that's when the heat stops flowing, and that's when the cup of coffee and the room are both at the same temperature. And this situation, such a situation, is called thermodynamic equilibrium. There is no more heat transfer that takes place. This thought experiment also proves that heat will not go from the atmosphere into the coffee, because the heat energy packets are already very concentrated. When this coffee was hot, there was already a huge concentration of heat energy inside the coffee. So, no more of heat energy is going to try to go inside. So, we've established that. We've established that heat does flow, and we've established that it also follows a certain direction. Then, how did we refrigerate this refrigerator? Because by nature, if the box and the room are in thermodynamic equilibrium, heat is not going to automatically leave. It is not going to, if we politely ask, it is not going to go out. Then how are we going to reduce the temperature inside this box if the heat wouldn't automatically leave? The answer is we are going to have to do some work for that to happen. It is not going to go by itself. We are going to have to push it out if that's what it takes. And that's what refrigeration is all about. There is a very, very simple and ingenious solution to this. We know that the heat isn't going to go anywhere outside of this box. But what if we bring in something else that is at a lower temperature, that has much lower heat? For example, if you take a block of ice like this and you put it inside the small box and you kind of lock it up, you close it up, what will happen is that now all of the heat that is inside of this box will start going inside of this ice cube. So the small box essentially loses some of its heat to the ice cube. So eventually the ice cube would melt, but after some time you will notice that the temperature of this small box has come down. It now has much less heat because it has given off some of its heat to the ice cube. Now, the biggest problem with doing this is if you want to refrigerate something for a long time, you cannot forever keep bringing ice cubes, because ice cubes are heavy, they are bulky, and if you have to, every time to cool something down, if you have to bring ice cubes and keep refilling them, that's a lot of work. You just want to switch on a button and you want something to work. So, ice cubes are are good, but they are a very impractical solution. Scientists, engineers, inventors, they just continue to build upon this small idea. This idea of bringing something else that is colder to kind of pull the heat outside of the system. And finally, they ended up with a refrigeration unit. In the next video, we will get right into action, so keep watching.